everyone, I am Safina Devi from V.O.Chidambaram College. Today let us look at a problem from a competitive exam and try to solve it. So we have a question here from net exam. Let f be the set of all functions from closed interval 0, 1 to closed interval 0, 1. If cardinality of this set f is equal to f, then there are 4 options. F is similar to closed interval 0, 1. F is less than the cardinality of closed interval 0, 1. F is greater than C, where the cardinality of closed interval 0, 1 is C. And the last one is F is countable. So we have to choose all the correct answers here. There need not be exactly one answer. Now looking at this, we can find out that it is a real analysis question. That is easy. But then we have to choose the deeper subject so that we can solve the answer exactly. So let us understand the problem. We have two sets, the domain and the codomain are both closed interval 0, 1, and we have a set of functions. All these colored arrows, they represent functions, say. So we have to count them. How many of them? So that problem is a countability problem. So this question, to answer this question, we must know the countability section in real analysis. So let us try to solve it. Let me try counting all the kinds of functions. Let us see what are all the functions here. So immediately, as soon as we think about functions, we think about identity function f of x equal to x. Next we think about f of x equal to 0. When I say 0, then we think about all constant functions. And then what next? There is a lot more functions. But if I keep on counting functions this way, I will never be able to stop. So this is a wrong way of counting. What next? We have to check if we have any formula for counting such functions. Luckily, there is one such formula. The number of functions from a set A to a set B is mod B to the power mod A. So that is a handy formula we can use here. In place of A and B, we have the same set closed interval 0, 1. So here mod A equal to C, as given in the problem, we have that is equal to C, and so mod B is also equal to C. And now the number of functions will be C power C. By the formula that we have above, the answer is C power C. Now what we have to do is, we have to compare this number with the size of A and say which is bigger or lesser, or are they both equal. That is our next problem. So the two numbers are here. We have to compare these two numbers, C power C and C. Suppose C is a finite number, we would have immediately told that C power C is greater than C. But what is C here? That is actually infinity. In fact, it is uncountable, right? Closed interval 0, 1 is uncountable. So what do we have here? Infinity, power infinity, and infinity on the other side. How do we compare two different infinities? So that becomes complex, right? So let us not think about it as infinity. Let us just look at it as C power C and C. So what do we know about C? It is at least greater than 2. So we can definitely say C power C is greater than 2 power C. In turn, 2 power C is greater than C. So we have got a result, C power C is greater than C. That is, the number of functions is greater than the size of closed interval 0, 1. So now we can try answering this question. Let f be the set of all functions from closed 0, 1 to closed 0, 1 itself, and we have cardinality of f equal to small f. Now the first option is f is similar to closed interval 0, 1. So when we say f is similar to closed interval 0, 1, that means capital F is equivalent to closed interval 0, 1. But we have seen that there are more functions than there are elements in closed 0, 1. So that one is wrong. We cannot choose that option. The next option, f is less than the cardinality of 0, 1. We have already seen it is greater than, so less than is definitely not an option. So that is also wrong. The next one, f is greater than c where the cardinality of 0, 1 is c. That is exactly what we have found out here, right? So that one we can give a tick. The next one, capital F is countable. We've already seen that it is greater than the size of closed 0, 1 and closed 0, 1 is uncountable. So then how can capital F be countable, right? So that is also a wrong option. So the correct answer here is only C. So that we have seen how to solve this question here in using countability. So what next? This problem is solved. In the process of solving this problem, we learnt a little more things about countability in real analysis. Using the concepts that we learned here, what we can do, solve more problems on countability. So you can go check for more problems here in real analysis, see if they fit into countability and then try to solve it. See you again later with some more problems in real analysis. Thank you.